Let's take a look at this problem. We got f of x is equal to x squared log base 2 of x squared plus 1. First off, we'll rewrite this using the change of base. And we can rewrite it as natural log of something over natural log of something. Now this will be natural log of x squared plus 1 over natural log of 2. The way the change of base works is whatever follows your log is always what goes up on top. Whatever your base is always what goes down below here. So then, natural log of 2 I can put clear out in front, because that's just a number. Then I got x squared times natural log of x squared plus 1. Product rule. This will be p, and this will be q. So I need p prime. P prime would be 2x. I also need q prime. And this is a chain rule applied to the natural log. The derivative of natural log of something is 1 over whatever, in this case x squared plus 1, times the derivative of whatever is right here, which is x squared plus 1. Well, the derivative of x squared plus 1 is 2x, so that's going to give us 2x over x squared plus 1. Now our formula is p prime q plus pq prime. Now the 1 over natural log of 2 will just remain out in front. And this is the derivative I should put. So p prime was 2x times q, which is natural log of x squared plus 1, plus p, which is x squared, times q prime, which is 2x over x squared plus 1. Now notice they both have a 2x in common, so I can factor that out. So we'll have 2x over natural log of 2, and then we'll have natural log of x squared plus 1 plus x squared over x squared plus 1. Let me see how far they take that. Okay, they say critical number is x is equal to 0. Okay. First off, if we got a single fraction, well, in order to combine these together, I can, and then I'll talk about why you don't even need to worry about this, but okay, so I'll put that over 1 plus x squared over x squared plus 1. Our common denominator would be x squared plus 1. So over here I multiply top and bottom by x squared plus 1. So I got x squared plus 1 times natural log of x squared plus 1 over, and I multiply the bottom part by x squared plus 1, plus x squared over x squared plus 1. So I got 2x over natural log of 2, and then I'll merge this into a single fraction. So we got x squared plus 1 times natural log of x squared plus 1 plus x squared over x squared plus 1. Now, this on top part here I really can't do much with. If you look at this first group, this right here, and this second group, there's really nothing I can factor out. I can multiply this through. Really wouldn't allow me to combine anything together. So let's just start setting things equal to 0. So I set 2x equal to 0, which gives us x equals 0. And you see they came up with a critical number x equals 0. Now if I set this top part equal to 0, I got x squared plus 1 natural log of x squared plus 1 plus x squared, and set it equal to 0. Well, this right here, I'm not even sure how you do it algebra-wise. We could plug it in the calculator. But no matter what, if I plug 0 here, I get natural log of 1. And I plug 0 here, I would get 0 squared. So it looks like 0 would be an option. Any other number, if I put it in here, will never give you 0. And I could confirm that. By plugging in the calculator. I'm just double checking. But x equals 0 would be the only thing. Now if I said x squared plus 1 equal to 0, if I were to solve it, take the 1 over, becomes a negative 1, drop the squared, put a plus or minus square root around the other side, that'd give us plus or minus I, which is no good. Okay. Now our only value here is x equals 0, but right up here, when you start dealing with this right here, when you got this x squared is always positive. Positive plus 1 is positive. X squared here is positive. X squared is positive plus 1. So when you got a positive plus a positive, there's no way that's going to give you 0 if you were to set this equal to 0, unless your answer is potentially 0. But 0 plus 0 would give you 0. So right up here, I could see that the only value that would benefit me is x equals 0, which we already found over here. So like I say, you didn't have to go through all that effort on that part.